Welcome to today's webinar. My name's Matthew McKnight. I'm a technical specialist with Autodesk. I work from our Melbourne office. And today we're going to be talking about integrated CAM workflows with Autodesk HSM. Now, why are we talking about CAM and machining at Autodesk? Many of you will have known for the better part of 35 years we've been a leader in design technology. But the reality is that Autodesk believes that design and manufacturing should be part of one seamless workflow. Now, most recently, you would have seen this recognized in the way that we have repackaged what we called previously the Product Design Collection and what is now called the Product Design and Manufacturing Collection to include advanced machining capabilities or advanced manufacturing capabilities in the form of Autodesk HSM. But what is HSM? So let's have a quick look at this. Well, HSM is advanced manufacturing technology that embeds directly inside your choice of design solution. It works for both Autodesk Inventor as well as SolidWorks users. So if you already have a design solution in place, then Autodesk HSM will slot into your existing workflow and complement your processes as it exists today. That's why companies like Kalitta Motorsport, which is a racing team in North America, adopted Autodesk HSM. It's because it enabled to work with their design solution, help them speed up their development process, turn around parts in a shorter period of time, and help them bring products to market sooner. If we look at this in a more visual way, we will all recognize this being, whether we're a designer or an engineer or a machinist, this typical workflow. So the designer and engineer will be sitting there doing the detailed design, conceptual work of a design, and then this will typically be then passed on to the machinist. Now, this could be the same person as well. We need to recognize that often the machinist and engineer or designer play the same role inside of organizations. The reality is that, for a long time, these have been separate systems. The system that you would use to machine your components was a separate piece of software which was different, in essence, to your design solution, resulting in the need to import that information, to set it up, to do all the toolpathing. Now, the challenge came when you recognized an issue with your design, which needed to be corrected. Maybe it was because of manufacturing, maybe it was because of some design oversight. The reality meant that if you needed to go back and make those changes, often it would result in redoing a lot of the work that you'd already done, importing, setting up, and toolpathing the design. The reality, by using an in-CAD version of your CAM solution, enables you to pass this information back to the design environment, make changes inside of this environment, and then pass more seamlessly back to the CAM environment, enabling a lot of the setup and toolpathing information to be retained between changes. I always like referring to local case studies. In this example here, we're talking about Robert Page Engineering. They're a New Zealand manufacturer, and they adopted Autodesk HSM to run inside of Inventor. Reason being is that they recognized that by using an in-CAD CAM solution like HSM, it enabled them to reduce their programming time, and this meant that they could be more efficient and more productive overall. Let's have a quick look at what this looks like in a typical workflow, and here we're actually going to be working with files that are supplied to us by Robert Page Engineering. So now in this instance, what we're going to do is pause for some reason. Let's see if we can kick it off again. There we go. If we look at this, what we can see here is that we're actually simulating the workflow to understand exactly, how the toolpathing that's being generated, whether it's likely to generate the components as we expect them to be, but also to look for any potential issues that we might encounter during the manufacturing process. And what you'll see here is we're using the simulation capabilities that come included as part of Autodesk HSM that enables us to do this. Now, if we want to make some design changes, we can, because we're already in the CAD solution. We can go back to the CAD environment, make some design changes, then switch back to our CAM environment where we can then retool path and then re-simulate the design to look again for any potential issues. Now in this instance you'll notice that as a result of the change we now encounter a clash between the tool and a part of the fixture or jig that's supporting or holding the part. Likewise, we could go back and maybe make some changes to the design of the part, but in this instance we can just as easily change the tool that's machining the part to help avoid this issue. We can regenerate that tool path, re-simulate the manufacturing process again, and again confirm whether we do or whether we are or aren't likely to encounter issues during manufacture. So that really highlights, some of the key advantages for using Autodesk HSM, which is a part of your design and manufacturing workflow. So let's have a look now at some of the key features around why you should use Autodesk HSM. We've already touched on some of those before. HSM is a comprehensive set of features that enable you to be able to share and leverage that data on the workshop floor. It integrates with inside of both Inventor and SolidWorks and enables you to run toolpathing for a number of different machining strategies from 2.5 axis right through to 5 axis simultaneous machining, as well as traditional turning, as well as mill turn configurations as well. It has direct links to the 3D models, and as we've seen in the previous workflow, you'll note that if you make changes to the design, they then go on to flow on and impact the machining strategies and toolpathing that you've generated. You have integrated simulation capabilities within there that help you find any potential issues and verify your toolpaths, as well as, and something we haven't spoken about, is improved machine efficiency through what's called adaptive clearing technology. So let's have a look at some of these in more details. Firstly, CAD integration. And as we've highlighted previously, it enables you to embed this CAM solution in either SolidWorks or Inventor. This provides for a much more streamlined workflow when passing information from design to manufacture and back again. It also offers a simplified data structure because a lot of the information is actually captured within inside of the original file. It can help cut down on the number of files that actually need to be managed, and this information can be managed via data management solutions like Autodesk Vault. It provides what should be a shorter learning curve because you already know how to use the design environment, so the user interface of working with the solution. It's simply a matter of then learning the features and functionality of the CAD environment. And because you have all of these CAD functions at your fingertips, this adds a lot of value to you as a machinist or a CAM user, because you can quickly move designs back into the design environment, fill holes and pockets and the likes. You can create setup information, even right down to work holding and fixtures can be created and incorporated as part of your design. So having the design solution offers you a lot of flexibility. Again, let's just quickly highlight this with a very simple workflow. We've set up a simple 2.5D part here that we've done the toolpathing for, and you can see here that it runs successfully, including some holes and taps that we're running. What happens if we wanted to make some change? We realized that we couldn't quite manufacture it, we need to make some change, or the designer or an engineer realized that he'd made a mistake, he or she had made a mistake and need to make some corrections. We can go back into that design environment, make changes to the sketches and the features, including heights, diameters, and so forth, clearances. And you can see here that we're changing almost all features that have been created in this part to show that across the board we can make numerous changes to our design and then shift back into the manufacturing environment and seamlessly update our toolpathing to suit. So switching to the CAM environment, we now regenerate our toolpath, which only takes a few seconds, and we can re-simulate that toolpath now to understand the likelihood that we're going to get a successful part. And as you can see here, as a result of making all of those changes, all of our toolpathing now follows the updates, and there's no longer the need to recreate a lot of that information. Now, we spoke about a little bit earlier about machine efficiency, and this comes back to what we call our adaptive clearing technology. And adaptive clearing is where we have constant tool engagement and constant material removal rates to help remove the peaks and troughs of actually machining material away in a very efficient manner. This can help shorten the mill run times or your machining run times. It can also help extend the tool life because we're no longer using just the tip of the tool, we're actually using the entire length of the tool. We actually machine with more efficiency and cut down on the wear and tear on specific areas of our tool. And you can also run at higher rates through the cut of your part as well, which can help improve that process. Now, adaptive technology is available in a number of different tool paths. So you can see here we have both 2D and 3D or multi-axis capabilities to run adaptive. Here we'll run a 3-axis milling capability to cut out the internal shape of our part. You'll note that this actually uses what is multi-core support. So all of the processes on our machine can be leveraged to generate this tool path, as well as cutting-edge linking, making this the most advanced roughing technology available. Now, once it's generated, we can quickly simulate this again. We've already seen this, and you'll see this likely again a few times. The fact that we can use simulation to verify our tool paths and make sure that we're going to get the part that we expect. Now, I'm not going to show the entire length of this one because it does take quite a while to machine out the cavities of these designs, but you can see here that we have generated our adaptive tool paths that quite quickly rough out a lot of the bulk material and then go into detailing the edges. What does that look like? And you can see here this running on our machine now. Just try it's a bit loud. This, is quite an impressive piece of technology, especially when you see it running on a machine. This can help you complete your parts faster, giving you an overall advantage in comparison to your competitors. And because you're using constant load, this can help decrease the tool and machine wear as well. It can reduce the likelihood of tool breakage because of the strategy it takes on part entry and corner engagement. And because you're cutting with the full depth of the tool, not just the tip, this results in higher material removal rates and better machine efficiency. So you can see there in the few seconds that I've been talking about some of the value, I've already been able to take off a large portion of material in this component using the adaptive technology. Okay, so moving on, integrated simulation and verification can help you in a number of ways. It can help, and we've seen already in some of the examples that we've used and some of the ones that I've created, it helps quickly verify that the toolpath that you've created is actually going to give you the final product that you intend to receive. It also helps find any potential issues with collisions, both between tools, the tool holder and the stock, as well as it also has machine statistics as well. So if you're looking to get an estimate on the machine running time or the total distance, maybe the number of operations and the tool changes that are required, you can do this very early in that process. Let's step through some of this information. So once we've generated our toolpaths, we can hit simulate, and there is a simulate icon up there that we can use just as well. And you can see here we can speed up or reduce, slow down, and we can even reverse this process. And we can look at it, in a number of different formats. So here we can see the tool holder, and the stock. But we can turn on the toolpath as is shown here. And we can show certain aspects of the toolpath as well. We can turn off the tool and just look at the material removal. We can turn on or off the holder. We can even turn on or off the stock. If we switch to the info tab, we get a lot of information about the position of the tool at that point in time, the operation, the machine, the verification that's taking place, and we can see there's already some collisions that are being detected, and statistics around what's the expected machine time. Now, if we want to, we can go further into this. We can turn on or off a stop a collision, which is really valuable because you'll notice if we skip forward in the timeline, speed up that process, give it a moment to catch up on itself, you'll find that this is important because often we can overlook an instance where we actually have an interference, but by having this option turned off, you'll find that when we do actually have a collision, in this case between the tool holder and the stock, it will stop at that point in the simulation. Now we can see that down in the timeline across the bottom of the screen, there's a number of interference and collisions that are taking place during this process. We can skip forward to understand those better. We can play them in those localized areas, or what we're going to do here is we're going to try and help avoid them. So in this instance, we'll edit the adaptive clearing toolpath that we've generated and simply change the tool that we'll use in this instance. Maybe we were hoping to be able to get away with some tool that we had available, and we now realize that we actually need to switch to a different tool to be able to achieve that job. We can regenerate that toolpath. It took a few moments to do, and then we can now re-simulate the toolpath. And you can see here in regenerating it, across the bottom of the screen we have completely green, which suggests to us that we shouldn't have any issues when comparing the stock and the tool for any collision. Now, furthermore, we have the AnyCAD technology. Now, AnyCAD technology comes as part of your Autodesk Inventor Professional subscription. And so this is technology that's commonly used by designers and engineers to be able to bring in CAD formats from a range of different third-party and native translated files. So what we can do here is this. Some of you might be thinking, well, that's not uncommon. Most systems that you use, design systems, will enable you to bring in a range of different file formats. The difference here lies in the ability to be able to maintain associativity with the original system. So whether it's SolidWorks or Solid Edge, or whether it's NX, or maybe it's CATIA, or even PTC Creo, you can bring these native files in without translating them and simply reference them. And in doing this means that if the file was ever to update, then you would be notified with inside of the system that it was out of date, and you can simply re-reference that original file. Now, this is fantastic if you're a machinist, because you can generate cutter paths using the files that you've imported, and then if the file was to ever change, you can then relink them to the updated files, maintaining your toolpaths. Let's have a quick look at what this looks like. So here I'm actually using a step file, which is one of the more common file types that you might be using. Now we'll import the file in, and you'll notice that the first option we're given is to actually reference the model. And this is the option that we want to select here. We can load the model and choose which bodies and parts to include. And we can, as well as turn on and off a number of other features and functions associated with the import process. Now, with inside of the CAM environment, now that we've imported the file, I can quickly and easily set up this part to be machined. Now, this is a turned part, so we'll change the operation to mill turn, change the stock orientation. I'm going to modify the stock size slightly, and we'll change the position, the stock's position relative to the model, and go OK. Now we can use a range of different turning operations to then turn this part. Now I've skipped over that process. I wanted to say, well, what happens, well, now we can simulate and see that we do actually have a process that's here that will show our part being machined. Now the challenge comes traditionally in that if the supplier of this information to you changes their mind or changes the design, or they realize there's an issue with the design and they were to resend this information through to you, that provides a challenge to you, because potentially you might have to have started all over again and redo everything that you've just done. The good thing is because we've referenced this file, not converted it, we've referenced the model. We're actually referring back to the original step file here. So if we overwrite or replace the file, or we simply change it, you'll notice here we get the little lightning bolts to say that we need to update the design. In updating it, you will have noticed that there was a number of changes to the look, the appearance, and the function of the part. We can simply go back into our CAM environment, regenerate the toolpath, re-simulate to make sure that we're successful, and you can see here that we have a whole new part based on all of the changes that will link through to that original step file. So very valuable, especially if you're working with suppliers of information to you that come in various different file formats and you want to maintain associativity with those. And finally, one of the last areas that I want to highlight here is the community. The community for Autodesk HSM technology is definitely another reason why companies are choosing HSM. And it's because of the activity of individuals like yourselves who participate on user forums. It's through regular webinars that are being run online through our user community. It's through social media activities, both generated by Autodesk and by our customers, as well as quite an extensive library and archive of information that teaches you how to use some of this information. You'll see some of it showing on the right-hand side of the screen there. The Autodesk Knowledge Network, which has got information about how to use the product, including help, tutorials, and workaround information, as well as outside experts. You'll often find people outside of the company are actually promoting the use of Autodesk HSM and its surrounding technologies. But finally, I want to finish off by talking a little bit about some of the toolpathing strategies. We won't be going into a lot of detail about this, as we could spend a lot of time talking about each of these, but I do want to highlight a range of capabilities that Autodesk HSM is well known for. Starting with 2.5 axis features. Now, these come as part of Autodesk HSM, but in many respects they come as part of a free 2.5 axis add-in called Inventor HSM Express, which is the Inventor version, as well as HSM Express for SolidWorks. Now, this enables you to do a range of different 2.5 axis machining operations through 2D pocketing, facing, profiling, engraving, and the likes. But the reality is that most customers are opting for the flexibility of using a CAM solution that enables you to do 3D milling operations. Now, why is it that you would pay for this technology when it's already available for free? For a number of reasons. By using the 3+ milling capabilities, you can cut down on a number of things. Fewer setups is one of the critical aspects. In this example here on the right of the screen that we see running over the next few minutes, and you can see on YouTube if you do a search under the Inventor HSM or Autodesk HSM channel for 2D versus 3D, you'll find that it can cut down on the number of setups from 4 if you're using 2.5 axis milling strategies to 2 if you use 3 axis. You can also reduce the number of toolpaths that you have to actually create to set up and machine the component, and in turn, because you're using this technology, you can help reduce the overall machine time. Now, the other thing to consider as well is that in using the free versions, the Express versions of HSM, you also need to have an existing seat of either Inventor or SolidWorks. The great thing about using HSM, if you're getting it through the product design and manufacturing collection, is that it will already include a seat of Inventor Professional. So there's no need to subscribe to that or maintain that license because it comes included as part of that process. Furthermore, there's a range of 3-axis features that aren't available in the 2.5 axis variant, including adaptive clearing for multi-axis strategies, horizontal parallel toolpathing, radial and projection toolpathing, as well as the ability to be able to do 3+2 machining or positional. Beyond this, Autodesk HSM also includes 5-axis machining capabilities, and this includes swarf cutting, multi-axis contour, automatic tilting in the instances where you need to use short tools, as well as 4-axis wrapped toolpaths. And finally, turning. Turning is another area that is available to users of Autodesk HSM. So if you're looking to do turning using things like profiling, grooving, facing, threading, chamfering, as well as mill turn capabilities, Autodesk HSM comes included with these capabilities. Now further to this is a range of other subtopics that we could talk about. Stock model with rest machining options, automatic tool holder collision avoidance, slope-based machining, CNC editors, probing, automatic sheet setups, setup sheets, and stock simulation and verification. Now we've covered some of those, but you'll see that there's quite an extensive set of capabilities beyond the machining strategies that come included as part of Autodesk HSM technology. So in summary, let's revisit some of the key reasons to consider Autodesk HSM. Firstly, adaptive clearing. It's going to help you and your business become more efficient in your machining processes. It's going to help you maintain or reduce the wear and tear on your tools and your machine. It's also going to help you cut down the machine time, meaning that you're running overall more productive than previously. We can help maintain associativity with the model using AnyCAD technology. So if the design updates, then it can update the toolpathing as well as associativity to your original Inventor models, the ones that you're actually generating with inside of Inventor. You can choose to run Autodesk HSM with inside of either Inventor or SolidWorks, so it's not necessarily for you to switch your design solution. And what comes in Autodesk HSM comes with a range of functional post-processes that are included as part of the software and furthermore available for download from our website and potentially even from the forums. It's a simple packaging. There's no extra modules associated with it, so when you subscribe to the Product Design and Manufacturing Collection, which is how you'll access Autodesk HSM, there's no upgrade path, so you don't have to pay additional to get access to, say, adaptive clearing technology or the probing technology or multi-axis capabilities. You get all of the technology that we've spoken about today in your subscription to the Product Design and Manufacturing Collection. Arguably it has the strongest CAM community available. We have an extremely active community of both Autodesk employees supporting things like the forums and content creation on YouTube, but also users creating information and providing feedback and responses through forums and a number of other social media platforms. We have free weekly webinars that are available for you to attend. And we also have local resellers in all regions who can help you get up and running and started as quickly as possible. So just finishing off, a little bit more about HSM and the Product Design and Manufacturing Collection, because the Product Design and Manufacturing Collection is the most likely the way that you're going to access HSM. If you're not, well, it's the only way for you to access HSM if you're not already a customer of HSM. Now, HSM was included as part of the Product Design and Manufacturing Collection, remembering our initial conversation around Autodesk's focus on streamlining workflows through the design and manufacture process. And it's because of this, by acquiring this technology through the Product Design and Manufacturing Collection, that you get access to a range of technology. So it doesn't matter whether you're a designer or an engineer or a machinist or even a factory planner, there's something for everyone inside the Product Design and Manufacturing Collection. Now, one of my favorite aspects of the collection is the fact that everyone gets a common tool set. So with access to the Product Design and Manufacturing Collection, you get access to your design solution, your data management solution, your simulation solution, and now your advanced manufacturing solution. And each person that has access to this collection gets access to all of those tools. There's no longer the need to fight over who has access to what piece of software. And the great thing, and hopefully we've shown this throughout the course of the webinar, is that many of these workflows are associative. You make a change within inside of the design environment, you go back into the CAM environment, your CAM tool paths will update. That's what we're really trying to place emphasis on, is the fact that a lot of these technologies work in conjunction with one another to provide an associative connected workflow from concept right through to finished product. In finishing off, let's look at an overall workflow. So here we have inside of our document management system, which is Vault, we can be managing all of our data. We can be sharing it Vault enables us to quickly and easily find the information that we're looking for. It's tracking versioning of our designs, and it's also helping us copy existing designs. And so what we do here is we'll make find our design and make a copy of it. And we'll maybe looking to make a design variant to try and make this part a little bit more efficient than what it currently is, to try and reduce its weight. Now the great thing about Inventor is that it comes with some of our shape optimization technology in the form of Shape Generator. Now Shape Generator enables us to, very similar to the way that we would set up a finite element analysis study, apply loads and constraints to our design, and then run a simulation to come back to then provide some insight on where within sort of our design material is required to be able to support the loads based on the information that we'd set up in our study. Using this as a template, we can then go into our design environment, make changes to the part, and then to be able to verify that, we can bring this back into our overall assembly, check for fits, clearances, interferences. But more importantly, we can even do structural verification on this. So maybe we're concerned that it might buckle, or maybe we want to investigate various different types of materials to be able to use. We can investigate this using Nastran InCAD's advanced simulation workflows. And then finally, when it comes time to actually manufacturing the parts, as we've seen in today's webinar, we can now move this through to multi-axis CAM capabilities using Autodesk HSM, where we can produce the finished products, including posting our code to the machines and running setup sheets that can be sent out to the workshop floor. So there you have it, the product design and manufacturing collection. Everything your team needs to design and make great products, now including Autodesk HSM. So by now you've probably got a whole bunch of questions, so let me try and address as many of those as I possibly can before we end this webinar. So what happens if you're looking for more information on HSM? Well, one of the first places you can go is to the Autodesk website. There's a specific page for Autodesk HSM, which will give you product information about all of the topics that we've spoken about today, plus a whole bunch more. If you're looking to understand what's recently been added to the content, just do a quick Google search for Autodesk HSM What's New, and you should be taken to the pages, the relevant page to the product that will highlight to you some of the recent changes and additions to the technology. And if you're looking for further insight, you can always head to the forums as well. The forums are great for participating as part of that community to gather feedback from other users on how they use the technology and to be able to gather some insight before you make that investment in Autodesk HSM. Furthermore, if you're looking to learn how to use Autodesk HSM, there's a range of tutorials that are available for you to use. It's on the Knowledge Network. If you just do a quick search for Autodesk HSM or something like Inventor HSM tutorials or HSM Works tutorials, you should find an abundance of tutorials that will help get you up and running. You'll also find the Autodesk HSM YouTube channel. So just go to YouTube and do a search for Autodesk HSM. You should find some really fantastic webinars and short videos around either specific pieces of technology or specific functionality. In this case, there's a great one by Lars on getting started with HSM that I can recommend for you. And finally, your local Autodesk partner or reseller is another valuable resource. So if you're trying to learn the technology and these other methods don't suit your style, or aren't giving you the information that you need, then your authorized reseller is definitely a place that you can go, many of which will actually have courses or can provide customized content to suit your needs. What about if you're looking for more information on post processes? Now, it's one area that we haven't really spoken about, but you can actually find a range of post processes that are available with the software that come as part of the installation process, plus additional post processes that are available on our website. If you're after, you can also reach out to your local reseller. So if you're looking to do post-customization, you'll find that local resellers and partners have the capabilities to be able to support your requirements around this. If you're looking to do something yourself, you'll also find an Autodesk post-processor manual, which can give you some insight as to how you can create or customize your own posts. And again, you can also reach out to the Autodesk HSM forums, where you'll find Autodesk users as well as Autodesk employees covering a lot of the topics around post-processor creation and customization. What about if you wanted to contribute towards updates of the software? You'll find that, like Inventor, you can go onto the Autodesk HSM Idea Station, where you'll be able to upload any ideas and contribute towards the design of the product, including voting for any other ideas that people have come up with. You'll find that the beta program, there's an active beta program for HSM, so you can log into the beta.autodesk.com website and actively participate in feedback on the newest release or early releases of the technology prior to commercial release. And you also find the HSM development versions, which are being released at a specific location. You can see the web address there. So if you're looking at getting access to some of these early release or development releases of HSM, these can be downloaded from the web address shown on the screen. Finally, if you're after updates, you can, like we've shown in a number of the other products that we've highlighted over the course of this webinar series, you can use the Autodesk desktop app, which is installed with your latest versions of Autodesk apps, and it will prompt you when updates are available. Now, if you would like to be able to download those as a more manual process, you can do so by going to manage.autodesk.com, where you'll find all of those downloads available for you to be able to consume. Otherwise, I'd want to thank you for your time today. I appreciate you attending today's webinar. If you're after some further information, please do reach out to either your local reseller. If you're wondering who that is, you can always do a search on www.autodesk.com/resellers and find your local resellers. You can find out further information by going to the Autodesk HSM website. And you can also, if you're wanting further information specific to the technology that we've talked about today, you can contact me directly on the link you see on the screen. Just a quick reminder before we do go, remember we do have one further webinar coming next Friday on large assembly management with Autodesk Inventor. If you'd like to sign up, please go to the link that's shown on the top of the screen. And do remember the upcoming event with John Saunders in Sydney. This is on Tuesday the 13th of March between 3:30 and 5. We're expecting quite a large turnout for that. So if you're looking to talk to other users of Autodesk HSM technology, this is going to be a great place to get that. Otherwise, thank you for attending. I appreciate your time today. Hopefully it's as nice in other areas of the world as what it is in Melbourne right now. It's beautiful and blue skies outside. Enjoy your summer afternoon, and hopefully we'll see you next Friday. Bye for now.